Let's just dive right into it. Today, we're tackling a massive shift in how software lives, breathes, and, well, survives on the internet. We're talking about Kubernetes, and specifically, how it helps engineering teams escape what I like to call the deployment nightmare. If you've ever dealt with those terrifying server crashes, or spent your entire weekend holding your breath, just praying a manual software release doesn't break everything, you're gonna love this. We're gonna see exactly how we evolved from sheer panic to, honestly, automated peace of mind.
So, let's start with the ultimate dread. Picture this. You launch a new feature, and boom, you get a massive traffic spike. Now, that should be a reason to celebrate, right? But instead, your CPU usage gauge rockets to 95%. The server goes deep into the red, completely crashes, and your users, yeah, they're slapped with a giant 500 error screen. When you're completely tied to manual scaling, any unexpected success actually becomes a catastrophic downtime risk. You literally just can't react fast enough.
To try and solve this single server anxiety, the industry eventually evolved to virtual machines. Basically, you take a physical server and slicing up into VMs, with each one running its own operating system. Sounds better, right? Well, it kind of introduced a whole new set of traditional deployment problems. Now you've got multiple apps fighting for the exact same CPU and RAM resources. If App 3 starts hogging memory and crashes, it can take down the entire virtual environment right along with it. Plus, engineers were still manually adding servers, suffering through incredibly long deployment pipelines, and just facing inevitable downtime during new releases.
You simply cannot scale a modern global application by having a human being sit at a terminal, frantically trying to provision hardware fast enough to catch a wave of user traffic. It's just far too slow. It's incredibly prone to human error, and the overall deployment risk is, frankly, astronomically high. The tech world desperately needed a fundamental shift in how we actually package and deploy software.
Enter the container. Instead of spinning up heavy virtual machines, we started putting our applications into these lightweight, standardized boxes. It's very much like shipping containers in the real world. A container brilliantly bundles up the app code, its specific dependencies, and a stripped-down OS layer into one neat, predictable package. And because everything is self-contained and isolated, it's going to run consistently anywhere. It runs exactly the same on a developer's laptop as it does on a massive cloud server. Honestly, it practically solved the old, well, it works on my machine excuse literally overnight. But, as always, that brilliant solution immediately created a brand new hurdle. How do you actually manage hundreds of containers at once? Sure, running one or two locally is a total breeze. But imagine the absolute chaos when your enterprise application relies on thousands of microservices, all running in different containers, all needing to talk to each other, update simultaneously, and share resources. Trying to manually link and manage this massive interconnected web, yeah, that's a completely new kind of nightmare. Which brings us to the hero of our story, Kubernetes. At its core, Kubernetes is a container orchestration platform that automates the deployment, scaling, networking, and recovery of all those containers. Think of your individual containers as highly skilled musicians in an orchestra. Well, Kubernetes is the conductor. It steps in as the ultimate automated orchestrator to tame all of that container chaos, making sure every single piece of software is exactly where it needs to be, right when it needs to be there. So how does this magic actually happen? Well, at the top, you have the control plane. Think of it as the master brain. It uses an API server to communicate, a scheduler to decide exactly where containers should live, and a controller manager to keep everything in check. This brain directs the worker nodes below it, where basic units called pods actually hold your containers. And an agent called a kubelet is constantly talking back to the master. This highly structured setup is exactly what provides that auto-scaling, self-healing, load balancing, and smooth rolling updates. Let's look at this in action, because the true power of the platform is its real-time self-healing and auto-scaling. When a massive traffic surge hits, you don't need to frantically page an engineer. Kubernetes detects the load and auto-scales from, say, 2 pods up to 10 instantly. It does this by constantly comparing your desired state, like, I want 5 pods, with your current state. If you only have 4 pods running, Kubernetes automatically steps in to correct it. It's just always actively managing your infrastructure in the background.
I really want to reinforce that self-healing concept, because this is what truly lets developers sleep through the night. If a container throws an error and dies, Kubernetes doesn't wait for a human being to wake up to a blaring system alarm. It detects the crash, terminates the bad pod, and spins up a brand new, perfectly healthy one in milliseconds. Zero human intervention. The system literally heals itself. How cool is that?
And this brings us to the global impact. Industry giants like Google, Netflix, and Spotify handle just mind-boggling amounts of traffic. Fun fact for you, Google spins up billions of containers a week, and they rely entirely on orchestration systems like Kubernetes to do it. When Netflix drops a highly anticipated new season of a hit show, they aren't manually racking servers. They rely on Kubernetes to deploy updates faster, scale automatically the second millions of viewers hit play, and recover instantly from any hardware failures across the globe without anyone even noticing a tiny drop in video quality. We've covered quite the journey today, right? Going from the utter terror of single server crashes and manual scaling, all the way to the automated, self-healing orchestration of Kubernetes. It's an absolute paradigm shift in how we build and run software. So the provocative final thought I'm going to leave you with today is this. Take a hard look at your own deployment strategies. Are you ready to let Kubernetes orchestrate your chaos? Thanks for hanging out for this explainer. Keep learning, keep building, and we'll catch you in the next one.